Hello and welcome back to my channel. Today I'm going to be giving you a crash course on the definition of a derivative. So the definition of a derivative is the limit as delta x goes to 0 of f of x plus delta x minus f of x divided by delta x. So the first thing that we can see here is that we can't just plug in delta x as our first step because we cannot divide by 0. And whoever you learn it from, these symbols might be a little different. They might be H, they might be A, they might be T, some other letter, but it all means the same thing. And so this gives us the derivative of any function. And when we find this function, it will be denoted as f prime of x. You put a little apostrophe in between the f and the x. So let's go ahead and do an example using the definition. So say we are given the function f of x is equal to x squared minus 3x plus 5. What we're going to do is we're going to apply this definition to that function. I'm going to go ahead and write this out as f prime of x is equal to the limit as delta x goes to 0 of, we're going to use something over delta x, probably be quite long. So we're going to plug in the quantity x plus delta x wherever we see an x. So this becomes x plus delta x squared minus 3 times x plus delta x plus 5. And then we subtract our original f of x equation. Don't forget to use parentheses so we can apply the subtraction symbol to every value in our function. So next up, we just need to expand all of this, condense some terms, move everything around, and then we'll be close to our answer. And then we can start seeing some terms canceling out. So we have an x squared right there, and a negative x squared right there, so those go to 0. We have our negative 3x and our positive 3x, and then we have our positive 5 and our negative 5. So then what we're left with is and now all of these terms have a delta x in common, which means it's all going to cancel out. So 1 delta x here is going to cancel out with this. This delta x is going to cancel with this. And then this delta x is also going to cancel with that. So we are left with the limit as delta x goes to 0 of, we have 1 delta x minus 3 plus 2x. And now we no longer have a delta x at the bottom, so we are no longer dividing by 0, and we can just plug in delta 0 for delta x to find our solution, which is, that becomes 0. This will just be 2x minus 3, which is equal to our f prime x. And that is the answer. So the derivative gives us a function that we can use to find the slope at any point on our function. So, because if you go back a couple of years, remember when you were trying to find the slope of a straight line, you would do, it'd be the change in y, so y2 minus y1, so the change in y over the change in x, so x2 minus x1. And so these equations quite similar. So whenever you see a delta symbol, this triangle in math, it usually denotes the change of some value. So this delta x right here directly corresponds to our x2 minus x1. And what we're doing is we're sending it to 0. So we're making it smaller and smaller and smaller between our x2 and our x1 until it becomes 0. And our f of x plus delta x minus f of x directly corresponds to our y2 minus y1. Those are essentially the same equations. So if we wanted to find the slope at any point on this equation, we could plug in that point into our f prime of x. Because if you think about it, it's not so simple to find the slope at some point on that equation. It's a curve. It's not a straight line. So say we wanted to find the slope at the point x equals 4. All we do is plug in 4 for x, and we get 2 times 4 minus 3, which is 5. And that is our slope. When x is equal to 4, this equation has a slope of positive 5. Thank you so much for watching. This has actually been part of my final project for my math degree. If you have any questions, I'd be more than happy to answer them in the comments below. Once again, thank you so much for watching and have a great day.